Today we will be discussing geometric sequence. And today's lesson objectives are: letter A, illustrate geometric sequence. B, define geometric sequence. C, derive the nth term of geometric sequence. And letter D, find the nth term of geometric sequence. Before we discuss, let us answer the following. Give the rule of each sequence and write A if arithmetic sequence and A if not. Letter A, negative 23, negative 18, negative 13, negative 8, negative 3, 2. Yes, the answer is adding by 5. So if you are adding a constant number, then the sequence is an arithmetic sequence. Letter B, 1, 2, 4, 8, 16, 32. So the rule is multiplying by 2. Therefore, it is not an arithmetic sequence. Letter C, 1/2, 1 and 1/2, 2, 2 and 1/2, 3 and 1/2, 4 and 1/2. So the rule is adding 1. So therefore, it is an arithmetic sequence. Letter D, negative 4, negative, or rather it is negative 1, 4, negative 16, 64, negative 256. Multiplying by negative 4 is the rule, so therefore, it is not an arithmetic sequence. Letter E, 5, 25, 625, 3,125. And the rule is multiplying by 5. So it is not an arithmetic sequence. Okay, letter A and letter C are examples of arithmetic sequence, while B, D, and E are examples of geometric sequence. Okay, let's take a look once again on example letter E, 5, 25, 125, 625, 3,125. So, we said a while ago that the rule of this sequence is multiplying by 5. So, the first term is 5. Multiply 5. Then the next term is equal to 25. Multiply again by 5. Then the third term is 125. Multiply 125 by 5, we will get 625. Then multiply 625 by 5, the fifth term will be 3,125. And this sequence is an example of geometric sequence. And a geometric sequence is a sequence in which each term after the first can be obtained by multiplying the preceding term by a fixed constant called common ratio, denoted by R. So, here the common ratio is 5. Example. Give the next 3 terms of the sequence 2, 6, 18, 54. So to find the 5th, the 6th, and the 7th term of this sequence, find the common ratio. And to find the common ratio, we have the following formula. R is equal to succeeding term divided by the preceding term. So meaning that you have to take the second term divided by the first term, and it will be equal also to third term divided by second term, and it is also equal to the quotient of a sub 4 divided by a sub 3. So if we are going to take the second term divided by the third term, then the common ratio is equal to 3. So let us now find the succeeding terms. To find the succeeding terms, a sub n is equal to a sub n minus 1 times r. So a sub n is the nth term, and a sub n minus 1 is the succeeding term, and r is the common ratio. So if a sub 1 is equal to 2, then a sub 2 is equal to a sub n minus 1 times r is equal to a sub 2 minus 1 times r, and a sub 1 is equal to 2. So 2 times 3 is equal to 6. So that is the second term. Then the third term is a sub 2 times 3 is equal to 18, since a sub 2 is equal to 6. Fourth term, so a sub 3 times 3, our a sub 3 is 18 times 3 is equal to 54. And to find the next term, that is a sub 5 is equal to a sub n minus 1 times r. Our fourth term is 54, so 54 times 3 is equal to 160. Next term, a sub 5 times 3 is equal to 486. And lastly, a sub 7 is equal to 486 times 3 equals 1458. So therefore, that the next three terms that we are looking are 162, 486, and 1458. Another example. Give the next three terms of the sequence 3, 6, 12, 24. Once again, let us find the common ratio by dividing the second term by the first term. So, a sub 2 is 6, and a sub 1 is equal to 3. So therefore, that the common ratio is equal to 2. Now let's find the fifth term. So the fifth term is a sub 4 times 2, and a sub 4 is equal to 24, multiplied by 2 is equal to 48. The sixth term is 48 times 2 equals 96. And lastly, a sub 6 times 2, and that is equal to 96 times 2 equals 190. So, the terms that we are looking are 48, 96, and 190. Another example, find the 10th term of the sequence 3, 6, 12, 24. So this time we are looking for the 10th term. Okay, this time since we are looking for the 10th term and it will take you so long to find the 10th term. So there is another way to find the 10th term. Since a sub 1 is equal to 3, and that is also equal to 3 times 1, can be written as 3 times 2 raised to 0, or 3 times 2 raised to 1 minus 1. A sub 2 can be written as 6 equals 3 times 2, and it is also equal to 3 times 2 raised to 1, or 3 times 2 raised to 2 minus 1. A sub 3 equals 12 equals 3 times 2 times 2. It is also equal to 3 times 2 raised to 2, or 3 times 2 raised to 3 minus 1. And the fourth term is equal to 24, can be written as 3 times 2 times 2 times 2, or 3 times 2 cubed, or 3 times 2 raised to 4 minus 1. A sub 5 is equal to 48, can be written as 3 times 2 times 2 times 2 times 2, or 3 times 2 raised to 4 equals 3 times 2 raised to 5 minus 1. So, let us now derive the formula so that you will have only a minute to find the nth term of geometric sequence. So, let us call a sub 1, a sub 2, a sub 3, a sub 4, a sub 5 as a sub n. Then, as you can see, the 3 is the first term, and 2 is the common ratio, while the exponent, as you can see, can be written as n minus 1. So, this is how you find the nth term of the geometric sequence, where a sub n is the nth term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. And since we are looking for the 10th term of the given sequence, let us now use the formula a sub n is equal to a sub 1 times r raised to n minus 1. So, the given r, a sub 1 equals 3, common ratio is 2, and we are looking for the 10th term. Therefore, the n is equal to 10. So, plug in or substitute 3 times 2 raised to 10 minus 1 equals 3 times 2 raised to 9, but 2 raised to 9 is equal to 512 times 3 is 1,536. So therefore, the 10th term of the sequence is 1,536. Next example, find the 8th term of the sequence negative 8 or negative 2. So, to find the 8th term, we simply find the common ratio of this sequence by simply dividing the second term by the first term, and the common ratio will be negative 1/2. And a sub 1 is negative 8, and we are looking for the 8th term. So, substitute a sub 8 is equal to negative 8 times negative 1 half raised to 8 minus 1. Simplify. That is negative 8 times negative 1 half raised to 7. But negative 1 half raised to 7 is equal to negative 1 over 28. Then simplify. A sub 8 is equal to 1 over 16. Another example, if a sub 1 is equal to 100 and r is equal to negative 1 half, what is the 11th term of the sequence? So this time, there are two given. A sub 1 is equal to 100 and the common ratio is negative 1 half. And we will find the 11th term. So the given r, a sub 1 is 100, r equals negative 1 half, and n is equal to 11. So 100 times negative 1 half raised to 11 minus 1, simplify. Negative 1 half raised to 10 times 100. So that is equal to 100 times 1 over 1024. And simplify gives us 25 over 256. So the 11th term is equal to 25 over 256. Peace. Peace.